Hello everyone. Today let us discuss about irrational numbers. As we saw in the last class, irrational numbers are the numbers which are non-terminating and non-repetitive and cannot be expressed in the form of p by q. That is in the form of rational numbers. For example, let us take the first case, a number which keeps on going, which is non-terminating. If we divide a number, it is non-terminating, it has no end, the decimal has no end, and it is non-repetitive. That means a pattern is not being repeated. See, 10 is not being repeated again and again. See, it's a different number everywhere. So it is non-repetitive and non-terminating, and this cannot be expressed in the form of p by q. Another example is root m. Root m might be anything such as root 2, root 3, root 4. Can this be? No, root 4 cannot be, because m, that is 4, is a perfect square. That means root 4 is equal to 2, which is a rational number. But root 3 and root 2 are not perfect squares. Therefore, they are irrational numbers. Like, so we can go on root 5, root 6, root 7, root 8. But root 9 is not an irrational number, because root 9 is a perfect square. The root 9 is 3. So anything except uh, m, which is not a perfect square, root m can be written as an irrational number. So on, any numbers. Another example might be cube root. Cube root, let us take cube root of 2 is an irrational number. Like that, can I, here root 8 was an irrational number, but cube root of 8 is not an irrational number, because cube root of 8 is equal to 2. 2 cube is 8. So this is not an irrational number. So root cube root of m, where m is not a perfect cube, that means root 8 cube root of 8 cannot be an irrational number. So any other example would do. Cube root of 3, cube root of 4 is also valid. And another best example is the value of pi, that is 3.1415, and it goes on. These are the examples of irrational numbers. Now let us see how to locate these irrational numbers on a number line. We know all these are integer values and rational numbers. We know how to locate rational numbers, we saw in the last class. But how to locate irrational numbers? Before that, let us have a look at the Pythagoras theorem. Let us revise it. We know that in a right angle triangle with angle 90 degrees, this is hypotenuse, perpendicular, and base. We know that hypotenuse square is equal to sum of base square plus perpendicular square. So this is the Pythagoras theorem, as you all remember. So using this, let us locate root 2 in this example. So how do we start? So let us draw a horizontal of 1 unit length, and then a line perpendicular to it with a line with 1 unit length. We all know how to draw perpendicular using a protractor. Now we need to connect both the ends. This is of unit length 1, this is of unit length 1. Let us call this as O A B. Then this distance is equal to root 2. So how did I conclude? It is by the Pythagoras theorem. The hypotenuse square OA square is equal to base square OB square plus the perpendicular square AB square. That is nothing but 1 square plus 1 square is equal to 1. So OA is equal to 1. Oh, sorry, 1 plus 1, that is equal to 2. So OA is equal to root 2. So now we know that OA is root 2. So how do we mark this on the number line? It is very simple. We need to take a compass, place the pointed edge here and place the pencil here and draw an arc. So this point would be equal to root 2. Okay, so how is this possible? Now let us take this. Now I'll draw a circle around this. I'll draw a circle. So if I draw a circle around this point O, then at any point, this is the radius A and this is also the radius. So if this is root 2, this is also equal to root 2 because this is the radius of the circle. I corrected the circle. So this is root 2. So this value would be around 1.414. So we would mark around 1.4. So you got this. This is the radius. So anywhere you take, the distance would be the same. Now I know the value of root 2. Now let me mark the value of root 3. So how do I do this? Again, now I know the value of root 2. Root 2 is around here. So what I do is I again draw a unit length of root 2 and I draw a perpendicular to that. The value of this perpendicular should be equal to 1 and I connect these 2 points. So I'll call this as C and D. It is the same thing again. So here again, let us write this. This OC would be equal to root 3. This value is equal to root 3. How is it? OC square is equal to root 2 base square plus the perpendicular square, 1 square, that is equal to 2 plus 1 is equal to 3. So OC is equal to root 3. So we know how to do it. So by this we can conclude that to locate root n on the number line, we have to first locate root n minus 1. So to locate root 2, first we located root 1, that is 1 itself, and then we drew a perpendicular and found root 2. And now to find root 3, the value which we found by root 2, we used that and drew a perpendicular over that with unit length 1, and this was root 3. And to mark root 3, we have to use a compass with one edge here and other edge here and draw a circle cutting the number line. This would be equal to root 3. Root 3 value is approximately equal to 1.7. 1.7. So we mark it there. So we know how this works because this is the same radius r of the circle. The distance is same everywhere. So now let us locate root 5 on the number line. So to locate root 5, first we have to have the value of 5 minus 1, that is equal to root 4. We know that root 4 value is 2. Yes. So now draw a horizontal line on root 2 with value 2. So the value of this OA, let us call that as OA. OA is equal to 2. Now we need to draw a perpendicular of unit length. This distance should be equal to 1. I'll call this as B. Now we need to join OB. OB is equal to root 5. How is this? We know that OA is root 2 and AB is equal to 1. So OB, by Pythagoras theorem, OB square is equal to OA square plus AB square is equal to 2 square plus 1 square is equal to 4 plus 1 is equal to 5. So OB is equal to root 5. So we found it. How do we mark this on the number line? We take a compass and then we draw a circle like this. So an arc, a part of a circle. So wherever this cuts the number line, this is the value of root 5. Now we have the value of root 5. So let us continue by finding the value of root 6. So how do we do that? One way we know that we have to draw a perpendicular out here of unit length, and then draw horizontal. So this is root 6 value. Or else we can draw a perpendicular to this line of unit length. Here, this is perpendicular. This line is perpendicular to OB. This is of unit length. This is also equal to root 6. So if we take a compass and if we join this, it is the same. This is root 6. This is also root 6. So there are two ways of finding root 6. You can do it by this way, or you can do it in this way also. So this is root 6 value. Before we proceed any further, I request you to by heart these values, because we would be using these very frequently. Root 2 is 1.414, root 3 is 1.732, root 5 is 2.236, and pi value is approximately equal to 22 by 7. Pi cannot be represented in the form of 22 by 7. This cannot, pi is not equal to 22 by 7. It is approximately equal to 22 by 7. This is the approximation value. Okay, so it is approximately equal to 3.14, and it goes on dot dot dot. Okay, I request you to by heart these values because we use it frequently. Now this is let us go for a more complex problem. Let us represent root of 4.3 on the number line. So till now we saw the roots of natural numbers. So now how do we represent this root of 4.3? This is a bit complex and not in the syllabus, but I'm just telling you for information which would be helpful for in your further classes. So to represent root 4.3, now draw a line with magnitude 4.3. Mark 4.3 on the number line. So I'll mark O and A. So the distance here is 4.3, the distance over here. And then I will take an unit length B, and the distance out here is 1. Okay. We saw that OA is 4.3 and AB is 1. Now I take the midpoint, that is OB by 2, that is equal to 4.3 plus 1 by 2, that is equal to 5.3 by 2, that is equal to 2.65. But we don't need this value, but because we know how to draw, how to bisect this OB value, we take a compass with the distance B, we mark it here, and we mark one here with OB, and we take the distance same OB and mark a line here, and OB we mark a line here, and we join those two, and whichever cuts, so whichever cuts the line, we mark this. So this is the midpoint. So now what we do is we take take our compass, take the distance from, I'll call this as P to B, measure this distance and draw a arc. it is a circle, a part, semicircle you draw from O to B. Now draw a perpendicular to A, to that line, to the semicircle. Now this distance, so if we draw a perpendicular to the arc, this distance would be equal to root 4.3. This distance from here till here would be equal to root 4.3. Now how is this? Let us prove that. So so we know that OB, we found that OB by 2 was, to find this I will take the help of the Pythagoras theorem again. So I know that I know that TQ is nothing but PB, that is that is nothing but OB by 2, which we already found out as 5.3 by 2. Now this is the hypotenuse. Now let us find this base PA. PA, what is PA? PA is nothing but PB minus this 1, minus 1, that is equal to what is PB? 5.3 by 2 minus 1, that is nothing but 5.3 minus 2 by 2, that is equal to 3.3 by 2. Now we need this distance AQ. So by Pythagoras theorem, AQ square is nothing but hypotenuse square PQ square minus PA square. So this would be equal to 5.3 by 2 the whole square minus 3.3 by 2 the whole square. So this is nothing but 1 by 4 into 5.3 the whole square minus 3.3 the whole square. I know that a square minus b square is a plus b into a minus b, that is 1 by 4 into a plus b is 8.6 into a minus b is 2. So this is nothing but 4.3. So AQ is so now let us look at how to insert an irrational number between rational numbers. So we know that if we want to insert, we have already seen that if we want to insert two numbers between 3 by 5 and 4 by 5, let us take two rational numbers. If we want to insert an rational number, if we want to insert a rational number, we know that the rational number is equal to s plus r plus s by 2, that is equal to a rational number is 3 by 5 plus 4 by 5 by 2, that is equal to 7 by 10. But if I want to insert an irrational number, that addition of irrational number is under root of r into s. That is, if I want to insert an irrational number between 3 by 5 and 4 by 5, I can, that number is equal to under root of 3 by 5 into 4 by 5. That is equal to 4 3s are 12, 12 by 5 5s are 25. Under root of 12 by 25 is the number inserted between 3 by 5 and 4 by 5. Extend this to irrational numbers also. That is, insert an irrational number between root 2 and root 3. So there are two numbers given, two irrational numbers given, root 2 and root 3. If we want to insert a number between these two, we have already seen that is equal to root of root 2 into root 3. So root 2 into root 3 can be written as under root of, the roots can be multiplied inside, so it is root 6. This can also be written as 6 power 1 by 4. This was just for your information. This might not be asked in the exam. Now let us look at exercise 1.2. What does it say? State whether the following is true or false. We have to give true or false. Every irrational number is a real number. Is it true or false? Yes, this is true, because real numbers, we already saw real number in the last class. Real numbers is equal to rational numbers plus irrational numbers. Irrational numbers. So irrational number, every irrational number is a real number. So next one, every point on the number line is in the form of root m, where m is a natural number. Is it true or false? It is false. So if we take a number line, let us plot one by one. Root 1 is 1, root 1. Then root 2 is 1.414. Then root 3 is 1.736. And root 4 is 2. Root 3, root 4. And root 5 is 2.36 something. So we know that in between any two numbers also there are infinite real numbers. Okay, so that means not every point on the number line is in the form of root m. That means if I take any number in between, it is not in the form of root m, where m is a natural number. Okay, so it is false. Now they are asking every real number is an irrational number. No, it is false, because real numbers is rational plus irrational. Not rational numbers cannot be rational, irrational numbers cannot be rational. So rational numbers is a set, irrational number is another set. Both consists of, both together form real numbers. So all real numbers, which includes rational numbers, cannot be irrational numbers. So it is false. So we will look at real numbers and their decimal representation in the next class. Till then, enjoy and practice well. All the best.